For this, the last example of section P5, I wanted to highlight the methods that I mentioned at the beginning about the graphical and numerical approaches to solving equations sometimes. And to do that, have a fairly simple example for you. We've been focusing mainly on the algebraic methods for solving, but now I just want to give you a couple of ways that you can see how graphs and tables might be used for that. I want to start with intercepts. Now, intercepts, as you know, are when we look at a graph. If I had some random graph here and look like that, my intercepts are basically just my x-intercepts in this case. So I want to find where it crosses 0. I can do that with this equation as long as I change it just a little bit. What I want to do with that is just get everything on one side and put it into my graphing calculator. So I'm going to subtract the 4 and have absolute value of x plus 1 minus 4, and I'm going to put that in for my y1 on my graphing calculator. So I've got a graphing calculator here, hopefully you can see it. The absolute value is going to come from hitting the math button, arrow over to num. It is part 1. Now if you have a newer calculator than me, your notation, the way it shows up might look a little different, but it means the same thing. So that's the stuff in the absolute value part, and then I'm going to subtract 4, and then I'm going to go to my graph. So as you can see on this graph, it crosses at a couple of spots. We're going to have 2 solutions to this one. So I could do this in a number of different ways, but one way that you'll be using a lot this year is the calc menu. So you see right above trace, there's calc. So I'm going to go second trace to get the calc menu, and I want to find out what the intercepts are. In other words, what are the zeros? And so it gives me a cursor, and it says left boundary, and then it's going to give me a couple other questions afterwards with left boundary, right boundary, and a guess. So what I'm going to do is I'm going to think about where is it that it's crossing, about right there, and I would get my cursor just to the left of it and hit enter. When I do that, it'll ask now for the right boundary. I want to get just to the right of that crossing point and hit enter. Then I'm going to get as close as I can, make a guess, and it looks like the 0 is x equals 3, y equals 0. Well, we don't care about the y here. We're just interested in what is x. So that is 3 for one of them. We can do the same thing for the other side by going back to the menu, find another 0. We've got left, right, and guess. Again, I'm going to get my cursor over there. So I got to get to the left of this one. It ends up being above it that time, but the left is the important part. Then I go over to the right, and then I hover over it as close as I can get, guess. And you probably saw that. You were probably guessing that already, but that is -5 for the x. So we have 2 solutions here, which we could have found it algebraically anyway. We got -3 and -5. Now we're going to take a look at the other ways to solve. We just talked about intercepts, but there's also intersections, and that's another way to use a graph, and I'm going to do it in a slightly different way. This one was intercepts. Now let's talk about intersections. So intersections, I'm going to approach it a little bit differently in that I'm going to take this and just make each one of the sides of the equal sign its own equation. So I'm going to do one of them, I'll call y1 absolute value of x plus 1. I'm just breaking this up. y2 is going to be simpler yet. That's just going to be 4. So I'm going to enter those in to my graphing calculator. I'm just going to clear out this stuff, and I'll put y1 as, I'm going to go back to the math button, absolute value of x plus 1. Keep in mind this is just a different method for solving the exact same equation, so we should get the exact same answer when all is said and done. We got those 2 on there. We're going to graph them, and we're going to see where they cross. Now, where they cross, there's another way we can use our trace or our calc menu for that. We can go second trace, and we can find the intersect. So number 5. Again, you'll notice it gives you a cursor. Now, Nice thing with this one is you can basically just go to the hover point and go to the point where it crosses and just hit enter 3 times, and it will give you the intersection. Again, we're only looking for the X here. It's 3. That was one of the ones that we got from last time, so that's good. We can do the same method again. We go to intersect and see if the other one works as well. And we hover over it. They ask for first curve, second curve, and a guess, but really if you get really close to it, you just have to hit enter 3 times, and -5 is the other one that comes out. So again, same result, just a slightly different method that we used. Last thing, and also because this is a graphing calculator problem, essentially, we're going to use the table to see if we can find out the same thing. So I'm going to revert back to the y1 that we had in the first example, back to this one right here. So I'm going to go back now and I'm going to just re-enter that absolute value of x plus 1 minus 4. So now instead of graphing this, what I'm going to do is go to my table function, second graph, and look in this table, and I'm just going to be looking for the places where y is equal to 0. So you'll notice that y1 is 0 when x is -5. Again, that was one of the solutions we already had. So we've got that. Then we go down even further, and oh, there is y equals 0 again, +3. That's what we had before as well. So that's just another method to solve it. Like I mentioned at the beginning, tables are not going to be one that we use as often, but it's another possibility if you want to use it to supplement.